Hey everybody. So this is our last section that we'll be doing before this next test. So we're looking to test on Wednesday. So on Wednesday, I will release the test on Blackboard on Wednesday morning, and I will give you until Thursday night, the next day, to have it done. It's probably better to go ahead and do it as soon as you can. Of course, it's open notes. Any resources you have, you can use. And it will cover chapter 9. Okay, so that'll be launched on Wednesday. So this is Monday's lesson, the very last section. After that, we only have 2 class days left, and what we'll be doing is reviewing for the final exam together. Okay? And I'll talk more about that. Excuse me. Sorry, I'm sleepy. I'll talk more about that later. So this is section 9.8. It's solving exponential and logarithmic equations. And really, I've typed it there, but this section is just all about putting everything together. So all that we've learned through chapter 9, we can mesh together to just solve some really easy equations here. Okay? Now, the biggest tip I can offer you is to remember we can switch back and forth between log and exponential form. Okay? That's a huge, powerful thing. Actually, it'll come in handy right off the bat. So these are questions that you may see on the test, things like this. Can I solve for x? Well, obviously, I can't think of any number that I could raise 3 to make it 7. If I raise it to 1, that's just 3. If I raise 3 to the second power, that's 9. That's not 7. But I can always rewrite this. If I rewrite this in logarithmic form, remember the base stays the base, and these two things will switch places. So this will be log base 3 of 7 equals x. And then, I can find this value from our last lesson. I know that I'm going to want to use the change of base formula to be able to type this in my calculator. So it'll be common log base 10 of 7 over log base 10 of 3, top log, bottom log. And that will give me the value. So I have my calculator pulled up here. So let's see, move over calculator. So let's see, log 7, so remember 7 log divided by 3 log, and then make sure you do hit equals because it will, there we go, 1.7712. 1.7712. So we're going to get the approximate value 1.7712. Okay? And so that's actually fairly easy to solve for that, right? Okay, awesome. Let's look at another example. That's really all we're doing today, is just putting a few examples together that are mixing and matching all these skills we've learned. So look at this one, solve for x. I don't really know what to do, but you can pretty much always guess that if it looks a little bit confusing, you should try to rewrite it. This is in log form, so let's see if I can rewrite it as an exponent. 4 is the base to some power equals something. Well, remember, this is in the logarithm. That's going to be what we're equal to, and what we're equal to will be the exponent. So they switch places. So 4 squared equals x minus 2. That's actually really easy to solve now. Now that I have written it in exponential form. So what's 4 squared? We know that's 16. We know that's 16. And then solving for this should be really easy. All I got to do is add 2 over to get x by itself. So x equals 18. That was a piece of cake. So in the first 2 examples I showed you here, the thing that made it really easy was being able to rewrite it. This one was exponential. We rewrote it as a log. This one was a logarithm. We rewrote it as an exponent. It made it easy to solve. Okay? So let's look at a few more examples, just practicing these things. We actually already have all these skills. There's not really any new skills in this section. It's kind of a good review section that the textbook has built in to just run over these things. Okay? So let's look at this example. And we say, this looks even harder. Why does it look even harder? Because I have 2 logarithms. But I want you to notice they both have the same base, and they are being added. So, think back. Remember what we could do if I had separate logarithms, and they were being added, and they had the same base? I could smush them into a single logarithm with that same base, and the inputs would be multiplied. So I could neaten this up a little bit more. I could multiply or distribute that x, right? Or I could go ahead and rewrite this. It's a confusing looking logarithm. Could I write it as an exponent? The base is 2, the exponent will be 1, and it will be equal to all of this. And then you should say, wait, I could solve this now. What's 2 to the first power? That's just 2. Can I distribute the x here? Let's see. Yes, I can. X times x is x squared, and x times negative 1 is negative x. So, we've studied a whole lot of quadratic methods in this class. I bet if I subtract this 2 over, so that I have everything, I'm going to carry up my work up here, equal to 0, I could use any of my favorite ways of solving this. If you wanted to, you could use the quadratic formula. That'll always work. You could try to factor it. If it factors, let's see if this factors. And solve each factor. I think it might factor. X and x minus 2 and plus 1. Let's see. Negative 2 and positive 1 multiply to negative 2. Negative 2 and positive 1 add to negative 1. So yeah, that's it. We factored it. You could have used the quadratic formula. You'd get the same 2 answers. So now I just need to solve, set each of these factors equal to 0. And solve. So let's see. Add the 2 over. So x equals 2. Subtract 1 over. X equals negative 1. So I got two solutions. Now, I will go ahead and tell you with logarithms, whenever I get 2, I need to check these in there. Before I even bother checking them, I want to remind you of the graph of a logarithm. Remember, a logarithm graph, no matter if it's increasing or decreasing, it never goes into the negative. It never takes a 0 or a negative input. It's undefined back here. So if I plug a 2 in there or there, it should be fine. But if I plug a negative 1 in, am I able to put a negative in there? No, there's no negative values in this thing. So we have a bad answer, an erroneous answer. So we throw that away. We get just x equals 2. So sometimes when you get 2 solutions, one of them will be a bad one. If it's 0 or negative, well, if it makes these inputs 0 or negative, then they're not any good. Okay? Alright. So pretty short lesson. There's just one more example I want to do with you to kind of takes you through all the variety or all the flavors that you may see on the test. So one right here. Once again, you say, I see 2 logarithms. I'm going to guess that I might want to put them together. Notice they don't have a base written. So that's understood to be base 10, so they are the same base. And they are being subtracted. So the rule tells me I can smush them into the same common log. But what's the relationship between the inputs? These 2 inputs are going to be divided. Remember, the first one comes on top. The second one is on bottom, equal to 2. Now, could I rewrite this so that I could solve it? Yeah, and you have to remember, what's the base there again? It's a 10. So the base of our exponent will be a 10. The exponent will be 2. And that will be equal to this x plus 2 over x. Well, I know 10 squared. That's just 100. And now I can solve this. This shouldn't be too nasty to solve. Now, I don't want to solve it with the fraction here. But I could say, okay, well, let's get rid of this fraction by multiplying both sides by x. So here we have x on the bottom, x on the top. They're gone. Remember, these x's do not divide out because it's attached to the 2 with the plus sign. Remember that. This one's being multiplied in. So I have 100x equals x plus 2. So now, can I get both x's on the same side? All I gotta do is subtract this x over. Alright, just a little basic algebra here. 100 minus 1 is 99. So 99x equals 2. Then divide both sides by 99. So x equals 2 over 99. Now that does not reduce, so I'm just going to leave it as a fraction. And there we go. X equals 2 over 99. We were able to solve for it. Awesome. So anyways, we will be taking our test next class. All your resources are available to you. All the worksheets. You may have those with you. The textbook. You may watch any of these videos again that you need to make sure that you do a good job on this final test. You'll have an awesome day, and you'll hear my voice again, I guess, on Friday.